Well, after several talks, very interesting content, we had people participating at different workshops, 360 blockchain, panel discussions since the very first talk when Sharid yesterday shared his perspective about artificial intelligence, teleexistence. Then we had a chance to hear Demi, Grace addressing 360, virtual reality, multisensorial, and inclusion in immersive technologies. We also had a chance to hear Tamara. And right now we are about to hear Onome Ofoman. Onome will address fairness in AI and impact on VR. Let me share with you her background. She works for Google office in New York, Google search, google.com. You know that search form, she works on that. But before Google, she studied in Stanford, graduated there, and she went to Polytechnic of Paris. And she's here today to address fairness and AI and impact on VR. We decided not to go literally in the translation, so let me explain the title of her talk. We developed several algorithms that will help to identify few things, such as facial recognition, applications of virtual reality. And some of those algorithms, they have some bias. How do we create fair algorithms that will set aside those preconcepts of all models? Now, Omani, you have the floor to make your presentation. Big round of applause.
All right. Hello, everyone. I hope you have your headsets on. This presentation is going to be in English. Sorry about that in advance. So thank you, Newton, for that wonderful introduction. So like he said, my name is Onome Ofoman, and I work on Google search, on search infrastructure specifically. And it's my pleasure to be in this wonderful city again. So I was here in São Paulo for the first time in April of this year as part of the Campus São Paulo Expert Summit. And it was there that I first met Newton, and it all resulted in me coming to speak with you today. So immersion, it's a topic that has gained significant traction in the last decades. And actually, Charit, the keynote speaker from yesterday, the first keynote speaker, he shared this wonderful slide which I decided to borrow. And it really just shows the progress that augmented reality and virtual reality have made in the past couple of decades. So what I'd like to focus today is on a little, like a technology that hasn't yet reached the level of augmented reality and virtual reality. And that's machine learning and artificial intelligence. So it's been gaining traction in the past few years, but really what I'd like to focus today is on fairness in machine learning and how that can have impact on immersive experiences and how the whole world experiences immersive experiences in terms of VR and AR. So today we will cover, first of all, what is machine learning and fairness? I'm sure a lot of you know what machine learning is, but fairness might be a new concept to introduce. Then I'll talk about the manifestation of machine learning on fairness, what causes it, what some of the potential solutions are, and then finally we'll end with the impact on immersive technologies on fairness, and then finally how virtual reality can be a way to mitigate this unfairness that we sometimes see. So in terms of implicit bias and how virtual reality can help there. Okay, so first, machine learning. What is it? Like I said, probably a lot of you already know, but the essential idea is that it's a technique used to predict future data based on historical data. So the whole idea is you're getting a lot of data about things that have happened in the past, using that to create models or patterns, and then based on these patterns that you've created, based on things that have happened in the past, use those models and those patterns to predict what might happen in the future. And then how does fairness fit into this? So when you do machine learning, essentially you're mining data. You're getting data from all over the web and all the other different places that data might be housed in. And now you might say, well, since machine learning and since these predictions are being done by computers and not human beings, then computers, they have no knowledge of any kind of bias. They're the essential unbiased system. But remember that the data that you're using to create this model has some biases in it. No data is completely impartial. And so because data is produced by human activity, the actual data that you use to create your model has some bias that the human activity that generated that data had. And actually, this is a graph that shows the number of research papers that have been published since 2011 till today on fairness in machine learning. So what this shows is that there's been a trend of people thinking about this topic and talking about it, researching it, and publishing data on it. So this is something that we have to start thinking about now, because it's something that's impacting the way we process data and the way we artificially learn from the data. So why do we talk about fairness? And when we talk about fairness, what do we really mean? So like I said before, a machine learning algorithm is only as good as its underlying data. And the underlying data might be unfair based on a couple of things. So the number one thing is the prejudices of its collector. So who's collecting the data? What kinds of questions are they asking? Are they asking the right questions to get the right input? Or do they have some implicit biases in their head that they might not be aware of, thus skewing the data? The second thing is prejudices of prior decision makers. And so if we think about data that's available on the internet, it's data that maybe might be based on the result of a court case. Now, if that judge was biased, the result of that court case that's available online would be essentially biased data. The third thing is societal biases. So we've heard from a couple of presenters today about how we think about things as a civilization, maybe men versus women, and which kinds of jobs are best suited for men versus women. These kinds of societal biases make their way into our data. And any machine learning algorithm that's based on this kind of skewed data on its own is unfair. And then the final thing is just pre-existing patterns of exclusion. So similar to the third one, it's how we think about, are we letting in people of a certain social economic class to be more present on the internet? Are we not thinking about having accessibility data available on the internet? Are we not thinking about having equal representation of male and female data on the internet? If all of these things aren't put into our model, then the model itself will be unfair. So let's look at some of the manifestations and how this could happen. So anyone who's watched any of my presentations of machine learning knows that I like to use fruits because it's one of the easiest ways to explain what could be going on. So let's say I've trained a vision model, a model that can tell me what something in a picture is. And I've trained this model to be able to identify fruits. But for some reason, I've only passed in apples and oranges. So again, the premise is I want to be able to identify pictures of fruits. But the data that I've passed into my model is only apples and oranges. Do you think this model will be fair? So let's see. What if I passed in a pear? Would this model be able to tell me really that, okay, this is a pear? No, right? Because it only knows about apples and oranges. It will likely tell me that this pear, no, it looks like an apple. So if the model only knows about apples, it would wrongly classify this pear as an apple. But this is really not what this pear is. So this is a benign example. It doesn't really have any serious consequences on anyone's life. It's just mislabeling fruits. Not a big deal. Let's consider a model that's used to predict whether a crime offender, so someone that has committed a crime, if we had a model that would predict whether that person will commit another crime. And let's imagine that this model was trained on data that's 90% male and 10% female. So there are more male data than female data in that model. And for some reason, this model also labeled all of the women in the data set as non-repeat offenders and the men as repeat offenders. So first thing, you have more men than women in this model. So that's obviously not fair. And then the second thing is that all of the data for women is skewed towards them not being repeat offenders, and for men being repeat offenders. So if we run a woman through this model, we have less information about women in general. And all of the women we have information about are supposed to be non-repeat offenders. So if we run a woman through, we would wrongly, maybe, label her as a non-repeat offender. And this is just because the historical data that we have is skewed in that direction. So even if she was a potential high-risk offender, we would label her as a non-repeat offender. And we would do the opposite for a man who maybe will not commit a crime in the future, but because the data we have is skewed to say he will be a repeat offender, then he will be labeled that way. So again, this is an example, not like the fruit. This could have lasting implications on people's lives. Let's consider a third model used to determine whether applicants to a university are admitted. So most schools have a process where you take a test, but in addition to that, you write an essay, submit your resume, your CV, talking about your interest and the things that you did in high school. Now, historically, in universities, there have been more male students admitted than female students admitted for computer science and other IT courses. So if we had a model based solely on historical data for computer science, for example, there will be more men or data on men than women. Now, some people might say, okay, this is not a problem. This is how the historical data is. But let's break that down a little bit. What's really happening there? So if you have more data on men than women, your data might be skewed towards saying, okay, if this person has extracurriculars that are masculine, for example, wrestling or playing football, then that person should be admitted. If they have extracurriculars that are more feminine, you might say like ballet or acting, then that person shouldn't be admitted. I'm not saying that this is what the data or this is how the model will behave, but as far as the model is concerned, there are more males admitted to the universities than females. This is, at least for computer science courses in general. And because the data only knows about what you give it, it will automatically attribute attributes for males as a higher percentage of them being admitted than attributes for females. Okay, so this is a real problem. And this is a problem because the historical data now, in this case, is not reflecting how you want the future to look. Yes, in the past, computer science students have mostly been male, but we don't want that trend continuing in the future. So we need a way to let the machine understand that even though historical data is this way, that is not something we want to replicate in the future. All right, so I'll break that down again. Why is ML unfairness happening? So first thing is lack of diverse training data. So if you think about it, right, by definition, if there's a minority population in the world, then there's less data available about that minority population. And we can use accessibility data as an example. In general, they're less disabled or people who need accessibility than people who don't. And so the data available on the internet is more about the majority case than the minority case. So we need our data to accurately reflect the needs of everyone around us. So if we want to make sure that our machine learning algorithms are fair, we need to make sure that we get the data we need into it. The second thing, which I mentioned before, is that our moral ideals or the direction we want the society to go in is not reflected in AI if you use solely historical data. A lot of bad things happened in the past, so we're trying to move away from that. But if we use data that solely relies on the things that happened in the past, then the future is likely to replicate what happened in the past. And then the third thing, and I think probably one of the most important things, is having diverse teams. So having people on your teams who represent different backgrounds, who you can use to test things on. There have been cases where vision artificial intelligence wrongly label Black people, for example, as different kinds of animals. Now, if you had a Black person working on your team that did that, then that algorithm would likely have been tested on that person at least, and those kinds of embarrassments could have been avoided. So having diverse teams is very important, not just for the mindset, but also to help you test and make sure that your algorithms work on different sets of people in the population. So how do we resolve this? Like I said before, just create more diverse data sets. If you're creating an AI algorithm, make sure that different parts of the population are represented. So think about what the potential use cases of your application are, and make sure that you get everyone in different populations in there. A very important thing, the second one, is to create algorithms that can explain their decisions. So this is important because most of the time when we think about AI or machine learning, we think about this black box. There's a model that's been created based on historical data, and you pass in an input, and it gives you an output telling you, oh, okay, I think this pear is actually an apple. But you don't know why it has labeled it that way. So having a way to reverse engineer the algorithm's decisions could help you see where your algorithm or your model falls short, help you see which kinds of diverse sets of data are missing, and help you deal with the first solution. The third thing is to add human involvement to the models. So like I mentioned before, we don't really just want to replicate history. We want to make history, or we want the future and the present to be different from history in most cases. And most ML algorithms actually involve a stage where you clean the data, you make sure it's ready. So within that stage where you're cleaning up the data, you could insert a part of the model that then is an input into how you want the model to behave now. So in more practical terms, if we look at the university admission decision, we don't really want to have the same percentage of male, female computer science students that we had in the future. We want it to be more even. So we could have a point in the model where we put that as an input saying, we want a 50-50 split. Don't make a 90%, 10% split that we had in the past. We want now in the present to have a 50-50 split for males versus females. So very similar to that is to constantly update and retrain your model with new data. The world is dynamic, things are changing every day. You need to be able to react to what your model is doing based on new data and new inputs that are coming up. And then the final thing is to just share best practices. Here I put, again, among machine learning vendors, but not just among vendors, amongst yourselves, amongst people in your team, people on different teams. Talk to other companies, see how they're dealing with this. So AI and VR, wonderful opportunities out there. So I know this conference is mostly focused on immersion, so definitely needed to tie in how artificial intelligence and virtual reality could function together. So when we combine artificial intelligence and virtual reality, we enable a lot of opportunities because the combination of just having a lot of knowledge based on data and immersion, so being able to fully put yourself into a situation, can be used to enrich a lot of various experiences. So it can range from how you interact in your workplace to how you diagnose diseases at the doctors. So let's see a few examples. So we can combine AI and VR in image processing, and we can have a continuous image recognition within a virtual reality display. So a practical example of this is security guards or guards at the airport can now automatically look at people and then identify and flag them as people on the most wanted list, or people on a terrorist list, or people on a no-fly list, for example. However, as we talked about before, data is not perfect, and people can always be mistaken for someone else that they look like. So what do we want to do here? Essentially, what we want here is, or what could go wrong here is that this guy in this photo, he could be anyone, but he could be wrongly labeled as Chuck Bennett, even though he's not. And I don't know if any of you have witnessed this, but I sometimes, when I'm in a picture with some friends, I wrongly get tagged by Facebook as some other black person that they know. And so if you think about how this could actually lead to issues when someone is trying to fly, and they just happen to look like someone on the no-fly list, but they're not actually the person. This is one of the dangers and one of the ways that virtual reality and AI, based on biased data, can actually influence people's lives. So another example is smart glasses, which can be used at conferences like this one. So the whole idea is you'd put on a pair of glasses, and when you look at someone, you can see their name, what company they work, what their interests are, and that could spark conversation. So on the flight here from New York, I watched this movie called The Circle, and it's by Emma Watson and Tom Hanks were in it. And a similar feature like this was used where when they're talking to their coworkers, they can automatically see the coworker's name, what team they work on, and what their level of connection is. So it's a really cool feature. But then again, data is imperfect, and if you have coworkers that look like other coworkers, calling them the wrong name, it's embarrassing. So we need to make sure that the underlying data that power these virtual reality experiences are clean and have as diverse set of data as possible so that we don't encounter these embarrassing situations. A final example where you can use VI and AR to make life better is in teleconferencing. So this is another example of how it can be used again in the work setting. So imagine you're on a call, a teleconference call with people you work with, and it's your first time working with these people. So again, you can have an overlay of a box showing, okay, this is their name, this is the team they work on, this is the location they're in, all of this useful information just to make the experiences of working remotely with other people easier. But then again, like I said, not enough data can lead to embarrassing situations. So we need to think about, as we're building these immersive experiences, think about how the data that we're using could negatively impact the impact we want our immersive experiences to give people. So I have two more things to talk about before we wrap up. So the first one is serious. It's virtual reality and how we can use it to mitigate implicit bias. So there's a study on how VR can be used specifically by judges in the courtroom to mitigate implicit racial bias. So let's examine the role that judges play in the legal system. So you have a judge, and they would manage the trial. They would determine whether a statement can be made by the defendant's lawyer. They determine what evidence can be brought to the courtroom. They can also decide the sentencing. So there's a lot that a judge is responsible for, And if they are biased in a way against maybe men and women, or against people of different races, or people of different social economic classes, this can be a very, very big issue in the legal system. And additionally, because different countries, in different countries, Black defendants normally represent a large population of the people seen in court due to sometimes over-policing or due to just systemic bias. Judges might sometimes unknowingly develop skewed proportion of crime by race. So they might think that Black people, for example, commit more crime than white people, just because of the numbers that they see in the court day over day. So how can VR help here? Virtual reality essentially gives people a chance to experience the world from different lenses. If we examine through research why implicit bias happens, we find out, and people have published this, that most of the time is because people do not see themselves reflected in other people. So there's this feeling of me versus the others, so a feeling of otherness. And essentially, it poses or comes from a place of potential threat. And so when we see people that are different from us, we tend not to essentially see ourselves reflected in them. So in this case, a judge could embody a member of a racial minority group. And that, by so doing, it could reduce the amount of implicit bias that they have, because if you can embody someone, you empathize more with them because you see yourself in them. So how does this work? Participants, so in this case is judges, they can undergo immersive virtual reality by wearing a head-mounted display, so you can see in this photo. And it replaces all of their visual inputs with pre-designed simulations. So in this particular experiment, a researcher, Tabitha Peck, she's an associate professor at Davidson College in the US. So she had light-skinned judges. Essentially, they entered the virtual environment where a mirror reflected back the different actions that they took. But the only difference is the image reflected back to them was not them, it was that of a dark-skinned person. So when the participant moved their limbs moved as well, but it was that of a dark-skinned person. So in this way, they're able to embody someone of a different racial group. And you can apply this to someone of a different gender, of a different social economic class. But this research proved that people who underwent this virtual reality immersion of being able to embody someone different from them began then to feel more empathy with this different group. And so Tabitha Peck, the researcher, was able to prove that doing experiments like this through virtual reality and immersion can help encourage open attitudes towards other people. So again, this is really, really important when people making decisions are different from the people that they're making decisions about. And I'm really, really happy that virtual reality can help us in this way. So the second thing, I said this was the first serious thing. The second thing is less serious. So it's just, a pet peeve of mine. I think that VR headsets of this day and age are not very inclusive. So this is what most people look like when they have a VR headset on. But this is what I look like. So if you look at my afro, you can't really fit a headset over or through the back. So it's my plea to any of you who are creating VR headsets or hardware, think about everyone. Think about the people that have an afro, people who have very silky hair that, that the headset can slide off on. Just, be generally inclusive and fair not only when you design software, but also hardware. Thank you.
Hello. Thank you for this amazing talk. Nossa, que palestra incrível, gente. Vamos abrir para as perguntas, então.
That was amazing. Thank you so much.
Dúvidas já ali? Posso começar? Eu já posso. Então, Onome.
Onome. About this research that you had just shared with us, when a person feels in somebody else's shoes, when you feel that empathy, when you experience a different time, a different moment with somebody else, have you disclosed, have you promoted the results of this research somewhere else? Because it's important not only to experience it, but also to understand the context. In virtual reality, we have a refugee field in Syria where decision makers, they felt indeed what was like living in a Syrian refugee field. And people, they end up crying afterwards after that really sad experience. And how to bring that as close to our public. We are developing some apps for virtual reality. What else could we do to foster and leverage this project?
Great point. I saw that experiment. So I think really, what it comes down to is making people aware of the things that virtual reality can help them do. So this is a wonderful way to do that, talking to people, sharing research that has been done. But I think the onus is on all of us to see, because we're all interested in immersion, interested in virtual reality. So we can ourselves look at the different research that has been done into how these technologies can be useful. Now, as far as sharing it with the general public who maybe are not as aware of new technologies, there are a couple of different ways. We can do this through schools, through youth groups, through church groups, through different non-tech groups that other people are part of. Because at the end of the day, if virtual reality can help make our society better, then it shouldn't only be limited to being shared in tech groups like this. There is a connection, for example, in that case between virtual reality and law. So in law groups, perfect example of a place you could share this. But the whole idea is sharing beyond our closed tech group of how these technologies can be used in a different setting. That would help spread it wider.
Obrigado.
Ambientes. Isso sim ajudaria a disseminação. Any other questions?
Here.
Primeiramente, obrigada.
Well, first of all, I would like to thank you for your lecture. My question is, how can we make sure that the data we're collecting are free from prejudice? Even though we have a diverse team, it's not always possible for you to have people from all social classes, different genders, different colors, and everything. So how can we start being aware of this and start thinking about this and really identify that what we are collecting there is free from our prejudices, our impositions, and our own visions?
It's a very good question, because fundamentally it's a data problem, because the data itself is biased. But when you, like you said, you can't have people from the different groups represented in your team. Sometimes you can't, but most times you can't. So what is really important there is to identify how exactly your model or your algorithm could be doing the wrong thing. So most of the time, you would have a model that's, let's say, 95% accurate. So it works 95% of the time, and then 5% of the time it doesn't work. Now, this is not bad if the 95% of the time that it works 95% of the time for everyone of all different groups. But what sometimes happens is that 5% of the time that it doesn't work is 100% of the time for some people. So it could be 100% of the time it doesn't work for people with long hair, for example, or people with short hair. So it's important that you identify how your model is going to be used, who is going to use it, and then test it that way. Because it's very easy to get different use cases. So let's say you have a model that's It's a vision model that helps you categorize pictures. So if you're thinking about categorizing different kinds of cats, there are a finite number of different kinds of cats in the world. Run it through your model, see how it behaves. Most of the times, what will happen or what you would find is that you would see trends where it works and where it doesn't work. And that for you is a link to how your model is performing. So the other thing I would say is this idea of leaving traces in your algorithms to understand better how it works. I think some of the times we get too caught up in this idea of machine learning is great, it's magical, let it do its thing. But when your algorithm is doing things that have impact on people's lives, it's very important to be able to explain to them why my algorithm classified them in a particular kind of way. I think very soon the legal system will catch up to what we're doing in AI, where it will be required for most people to have a way to explain what their systems are doing. And so having that in place will help you see specifically what's going on and see cases where things might be going wrong. Yeah.
Thank you for your lecture. Thank you once again. It was really nice. A round of applause.